All right, welcome. I know we still have people that are finishing their breakfast and coming in, but we want to be on time. So we're going to kick off this morning. Instead of a welcome, we wanted to actually give just an overview of a very important process that's going on right now. If you're not aware, OSHA has proposed a new set of regulations. What they're actually doing is expanding or proposing to expand the fire brigade regulation. And this is incredibly important because what this would do for the first time is expand coverage to public safety firefighters in the public realm. We would start to actually have the same protection benefits that are enjoyed by every trade union out there and private sector fire brigades. And just to get, there's a lot of chatter online and social media about this, but we wanted to have one of our representatives from the IFF, Scott Mullins, from our governmental affairs team, really just give you a 15-minute overview of the OSHA standard. We're going to have a webinar that's being released, I think, this week. And then on the 24th, we have a live webinar where Scott and I will talk about the OSHA regulations and submitting comments because OSHA wants to hear from you. So, Scotty, it's all yours.
Yeah, thanks, and good morning. My name is Scott Mullins. I'm, as Sean said, I work in the Government Affairs Division at the IFF, and I'm currently state president of the Professional Firefighters and Paramedics of North Carolina. I worked in Asheville, North Carolina for about 20 years and retired last May to take the job at the International. So as Sean said, the OSHA standards that are out, the proposed emergency response guidelines, will have the biggest impact on the fire service since SCBA's. It's been decades since the OSHA rules even been looked at. I thought we had some people from Michigan in here yesterday. Is anyone from Michigan in here? Indiana, any of you guys? Okay, well, good. We'll just talk about Ohio then. So Ohio does not have OSHA for public employees. But if firefighters from Ohio are responding into a state that does have, that is an OSHA state, then they will be mandated to follow the OSHA guidelines. So if you run mutual aid into Michigan or Indiana, for example, you would have to meet those mandates. And also, your collective bargaining agreements are subject to state and federal law, and they must at least be as strong as the standard. The Supreme Court has already ruled on this, and so honestly, I would say most of the departments in Ohio are already following these standards and won't be impacted, but some of the smaller departments may not be. So, and employees are empowered under the OSHA Act to file any complaints. So if the department isn't following, then you can follow those complaints and not worry about termination or anything else. So, but getting into the standards, it's about 608 pages, I think. And so what we did is we put together subject experts at the IFF, and you know, Sean being one of them, and we broke down the subsections that deal with the proposed changes, and that's about 60 pages. So if you're going to read any of it, really focus on those changes, and you know, eventually we would like you to put comments on why you think it's good, and add those comments to the Federal Register. But just getting into some of the standards, just show of hands, has anyone even looked at the proposed standards out there? It's so it's about 5 people in the room, and that seems to be pretty normal, right? And so we're kind of relying on other people in our department or our labor leaders to do that for us, and that's what we've been doing at the International here for a couple months. There's these different subsections start with. They talk a lot about emergency response teams and workplace emergency response employees, and that's really just kind of dealing with, for example, if you're an electrician at the Andersons in Maumee there, and a fire breaks out, they have a team that will respond to that fire, and that's what they're talking about with the workplace emergency response employees. Those are like the electrician that has turnout gear, and he's an early response person. So his day-to-day job is doing electrical work, but if an incident happens, he switches into this firefighter before the Emergency Service Organization, or ESO, arrives. So, um, so the proposed rule, the first one is it starts at subsection C, and that proposed rule requires for places to establish those response teams in case there's an emergency. And I'm just going to go through these subsections. I think it's the best way for everyone to sort of understand what's going on. Subsection D, ESO establishment of ERP and emergency service capability. The proposed rule would require organizations like the Cleveland Fire Department to it's designed for to provide a planned response to reduce injuries for the responding members. A lot of these are really just about creating plans for the safety of the workers and the citizens they protect. And so, moving through subsection E, it's a seat at the table with management, and this is a huge deal, especially in the Southeast, because a lot of the states don't have collective bargaining and aren't able to talk about what they need for their job, and OSHA would actually mandate that the employees are sitting down with the employers. Moving through, subsection F, which is risk management plans, and essentially it's based on the community needs, and it deals with providing training with PPE. It looks at vehicles, infection control. It's basically a process where emergency service organizations and workplace emergency response employees are not meeting operational expectations, and it develops a reasonable timeline for implementation to meet those guidelines for the community. Subsection G deals with medical and physical requirements. It's very interesting because for us in North Carolina, we're advocating hard to get physicals, and it doesn't happen in a lot of our departments down there, and that's the same for a lot of the departments in Southeast. And when this first came out, there was a lot of concern from especially some of the departments in the Northeast were concerned that their information would be shared with their employer. And so what we are advocating for is, yes, we want physicals, but we also want to leave it up to the locals, and we want them to figure it out with their collective bargaining agreements. So we want them to have the physicals, but we want them to be able to go and get those physicals on their own, maybe, and not have that information shared. So it would essentially be you go to your doctor, and they sign off just saying that you've met the physical requirement, and that would be it. So that information would be private. But again, it's one of those things where we're out there and we're advocating for early detection cancer screening, and at the same time, we can't be saying no to physicals. So definitely a huge benefit. Subsection H deals with training. Basically, it looks at qualifications for officer training, for technical and hazardous materials qualifications, wildfire response, marine fire, all these training guidelines that need to be met, and it just lays it out there for departments. Subsection I is facility preparedness. That looks at your fire department and their ability to operate safely, I guess, making sure that places have smoke alarms, sprinklers, a place for contaminated PPE to go, washers, dryers, whatever you need to make sure it might sound stupid for you guys up here, but there's a lot of places, especially again in the Southeast, where they just work in some really bad firehouses, and so this would work toward improving those firehouses. Moving through subsection J would be the emergency service organization, facility preparedness. Again, some of this is a little bit redundant, but it's looking at similar issues that for, you know, is your PPE in your bunk room, or is it in the base? Like, we're trying to get away from all that, and subsection J addresses that from OSHA. Equipment and PPE, is your turnout gear made of PFAS chemicals? The standards actually do look at what the gear is made of, and it looks to eliminate hazardous chemicals from being in our turnout gear. It also looks at is your apparatus 25 years old and operating without brakes? One of the examples that gets used a lot of times is there was an apparatus up in Boston, and they had written down that it had brake problems, brake failure, and it didn't go anywhere, and ended up the engine went through a building, and they lost a firefighter. And so OSHA is addressing that stuff too. Pre-incident planning. Yesterday we talked about EAPs. It's very important for our firefighters to get out and look at the buildings that they're going to be responding to. They need to have an idea of what hazards are in those structures before they get there for a fire. Subsection N is a little bit redundant. Again, it deals with pre-incident plans. Moving through O, looks at incident management system. As crazy it sounds, there's a lot of departments that don't operate with IMS, and OSHA would mandate that departments do follow those guidelines. Subsection P deals with areas of concern in structure fires, highlighting the 2 in, 2 out. That is something that, as Sean said, has been getting a lot of traffic online. Again, I mean, no one has, I don't think anybody in this room or anyone that I know of has not done what they needed to do when they arrive on scene if there's an emergency situation. No one's sitting there and saying, oh, wait, I got to wait for 2 other people before I get in and rescue someone. I mean, we've found ways to do our job every time we needed to do our job, and we will continue to do so. So, again, I don't think there's a single case out there where someone has been sued for the 2 in, 2 out. Post-incident analysis, that's subsection R. We believe it's important, and OSHA does as well, to look at incidents and figure out how we could have mitigated them better, and what changes need to be made in the future to make things safer for our firefighters and the citizens we're sworn to protect. And then finally, program evaluation is subsection S, and just looks at deficiencies that have to be identified in your department, how you respond to emergencies. So that's 18 subsections. And, you know, for me, I'm working on my comment right now. And in 2011, our department lost a captain, Jeff Bowen. I don't know if you guys have ever looked at the incident. Our department, we took a very aggressive approach to how we went about handling that situation, and we were honest with ourselves, and we found a number of deficiencies, and we actually, excuse me, and then when I look at the OSHA proposed ERGs, every single issue that we had could have either been avoided or we followed it afterwards. And I think had the OSHA standards been in place, we wouldn't have lost Jeff Bowen. He's a 37-year-old captain, one of the best firefighters we had in the department. And it was everything from communication breakdowns to improper equipment, poor SOGs. It was just one problem after another. Not enough people on scene, inefficient, well, poor training. We could have done a better job at that. It was a high-rise fire, and so I'm actually using that example and applying everything from the OSHA standards to each of those as I go through. And that's what I would encourage you all to do when you look at the standards. Think about someone that you lost at the department, or maybe as a neighboring department, or maybe look at an injury that you suffered or one of your coworkers suffered, and write how the OSHA proposed standards would have positively impacted that situation had they been in place. You can submit your comments. You go to www.federalregister.gov. And then it's the emergency response standard is right there. It's the proposed rule by OSHA. They're taking comments until July 21st. We're going to be doing a webinar on how to submit comments, and just it'll be more information. It'll be a deeper dive into it, and that's going to be on June 24th. So again, the comment period just got extended another 30 days, and it's going to close down July 21st. And so we are really encouraging our professional departments to do that. We just had a hearing about a week ago. Congress had a hearing, and we went and spoke. We had two people testify on our behalf. There were a couple of volunteer chiefs that were there, and they spoke against it. They actually said the standards they felt were pretty good, but they said that they couldn't afford to do it. Congress doesn't have jurisdiction over OSHA. As you all know, that falls under the president, and so I guess I'm saying that, you know, whether they like it or not, it's OSHA is going to make the decision. So, yeah, the 60 days prior, OSHA will post a hearing date, and the IFF will file an intent to appear. Anyone in here can file an intent to appear. You don't have to actually. It is going to be streamed. You don't have to actually show up. You can file your comments afterwards. But the OSHA is working off of best available evidence, and they're looking at the comments to use as best available evidence. So your comments are very important to getting these standards done. There's a lot of focus for us on labor relations in this as well, and we're very optimistic that it's going to get through. So does anyone have any questions on it? Yeah, please. Oh, would you mind going to the microphone? Sorry.
And really short. I don't work for a volunteer department, but that's my question. We do a lot of training for outlying departments that are volunteer. So when you brought that up, that was my question. Is there going to be any federal funding for these small volunteer departments for this?
At this time, they haven't decided about federal funding. I know there's federal funding out there, you know, and they're able to get a lot of the grants that we all apply for right now. But as far as federal funding just for these specific needs, not at this time, no. And that is, again, that's their big argument. And they are looking for a carve out, and so it is possible that the volunteers may not be covered. But I guess we'll wait and see what OSHA thinks. I don't know if that helped.
And to add on to that, you know, even big cities, and I'm sure you guys are all aware, they're always complaining about money. You know, with our CBAs, they don't want to give us raises, blah, 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 blah. You know, that's going to affect us as well. So I guess it's not just a volunteer question, it's for the big cities as well. So my question is, really, what is the benefit for us versus, I guess, the pros and cons, if you could delve into that?
Yeah, and for us, you know, our big argument is, you know, it's safety, and that's our number one priority, is that all of our members go home at the end of the day, and so that's on the on the employee or the employer to come up with how they're going to pay for it. And again, it's show me your budget and I'll show you your priorities. So is priority going to be safety? And I would like to think, yeah. I mean, they don't seem to have a problem for police officers. I mean, they do what they need to do to make them safe, and I think they need to do the same for firefighters.
I just want to add to that. There is nothing in this proposed OSHA regulation that is above the minimum that's already required in our standards. Nothing. Departments should be doing this already. And as far as it goes to the training, we have minimum requirements in the state of Ohio now. That doesn't, I mean, they have to be providing the training now, right, Chief Slomer? They have to do their training on time. So to Scott's point, OSHA is actually just propagating forward the minimum standards. They're proposing 46 standards that either you meet the equivalency or you meet the standard itself, such as in the PPE standard or NFPA 1910, which is the vehicle maintenance standard. They have exceptions, so you don't have to retire the gear after 10 years or the apparatus after 25, but you have to maintain it. You have to do that annual inspection on your apparatus to make sure that they're fit for duty. We have to do an annual inspection of our firefighter to make sure they're fit for duty. And we have way, way too many examples of early detection saving our members' lives. And there's no excuse for a firefighter not to get an annual physical. And what the level of that physical is, what we're saying is you don't have to do it to the NFPA 1582, but there has to be an annual physical. We'd like to see an enhancement for early detection, especially in our younger firefighters, because we're seeing a lot of cancer rates, especially in younger firefighters, and rare cancers. But, you know, again, that's going to go down to a jurisdictional negotiation. But I want to make it clear, there is nothing in these proposed regulations that is beyond what the current standards already require. Yep. Ready?
Yeah.
Checking out your notebook.
Oh, yeah. Thank you.
Thanks, Scott.
Yeah, thanks.
So we have a whole internal team working on this to prepare our comments. And just to finish up on that, OSHA wants to hear from you. They don't need a technical justification or a technical support on your comments. As Scott mentioned, they want to hear your experiences. Are you losing members or members getting injured because of a lack of training, because of a lack of equipment or the failure of equipment? You can simply submit a comment, as Scott said. You know, Joe Smith would not have gotten injured if he had received some training. And one of the examples we use is Newark. Newark is one of the largest ports in the U.S., totally reliant on municipal fire department response for any incident within the port, and yet no training was provided to that fire department for response to a marine fire. That's inexcusable. So we're going to move on. We do have a grant in to develop marine training for land-based firefighters. So FEMA, if you're listening, give us good grades on the grant. But we're going to get into building construction, specifically mass timber. The first presenter was actually retired from the Baltimore officers. When I first met Ray, he was the fire marshal in Baltimore City. I do not hold that against him, although he is a Ravens fan, but, you know, team Steeler. But I come to know Ray over the years, and now he's working for the American Wood Council, but he still is the fire service at heart. And Ray's going to talk about the fire testing that we did going into the mass timber building in this whole process. And I ended up being the chair of the fire work group for the ICC Tall Mass Timber Build, ad hoc committee, which is was it 18 months, 2 years? Yeah. 2 years of my life I'll never get back. Mm-hmm. Yeah, but there's a long story to it, and I'll present on it here. But Ray, after you.
Thank you. Let's see here. Good morning, everybody. I am from Baltimore. Some people think that's a dangerous place. I assure you it's not as dangerous as standing between Sean DeCrane and a microphone, but I'll do my best. So anyway, Sean had mentioned the Tall Wood Ad Hoc Committee. The way the ICC works, for those who don't know, whenever there is a singular subject that needs to be investigated, they create an ad hoc committee as opposed to giving it to one of ICC's standing committees. And Sean was on that committee. And the project scope was to explore the science of tall mass timber buildings, investigate the feasibility, take action to perhaps create a code proposal was exactly what it did. And the reason that was formed was because in the building code in chapter 1, you can build under what they call alternative methods and materials, which means that if the code is silent on a certain issue, if you can prove equivalent safety, then you can build it. And this is an example of a building in Milwaukee called the Ascent. It actually goes above what the current code allows because it was built under the AMM process. And building officials said, listen, we need guidance on what we should allow and what we shouldn't allow. The Ascent is 25 stories in total height. It's 284 feet, which is 4 feet higher than the tallest wood building in the world. It's actually 4 feet higher, or 14 feet higher than the code allows nowadays. You had a 6-story concrete podium with 19 stories of cross-laminated timber supported by glue-lam beams and columns. This is actually what it looks like nowadays. It came online last summer. It is fully occupied. The first 5 levels are parking garage, has a transition level with a pool and a fitness center, and then it has residential above it. This is by far not the only mass timber building in the country or even the world. It is the biggest. You actually have one right here in Cleveland, the Intro, which I believe is 9 stories tall, that Sean and I toured when it was being built. But the ad hoc committee, they had performance objectives before they would try to form any code requirements. So a couple of these were no collapse under a reasonable scenario of fire with complete burnout, with no fire suppression or sprinkler protection, no unusually high radiation from that building to the buildings around it, no unusual response if a building around it catches fire that it would have to be an exposure. Also, no unusual fire department access issues which can occur during construction, highly reliable egress systems, and highly reliable fire protection systems. Now, this is a compartment burn that took place in the ATF lab in my home state of Maryland. You can see, I put this picture in here because you can see the actual scale of the mass timber. It can be up to 7 inches thick, 8 feet wide, 40 feet long, and weighs 3 tons. I say weighs in the present tense because after this fire testing was over, they actually repurposed all this CLT and used it for housing for Yale architectural students. Cross-laminated timber basically is 1x or 2x lumber that is pressed together in laminations, and each layer is crosswise to layer above and below it. So you have a center panel, and then the panel above and below it are perpendicular to that one, which gives it extra strength. That's why it's always odd numbers of laminations, 3-ply, 5-ply, 7-ply. And it's actually more like precast concrete construction when it goes together than it is the traditional lightweight wood that you're used to. It's panelized construction that's fabricated off-site, brought on-site, and assembled together. I believe the Intro in Cleveland used a combination of 3-ply, 5-ply, and 7-ply CLT, depending on the application. And it was a hybrid black and white spruce, actually. Yep. So cross-laminated timber is new to us, but it's not new to the marketplace. It's got its first patent in France in '85. You started seeing buildings built in the early 2000s, usually in Europe. There's over 500 CLT buildings in England right now. I know that adhesives are a big issue with the fire service. Now, the CLT adhesives in North America are polyurethane-based. They have to meet a 320, PRG 320 standard I'll talk about later. And the New York State LC50 standard, it's a toxicity standard, and the burning of solid wood is no different than the burning of CLT. And in fact, you don't even get to the first bond line for 1.5 inches or 1.75 inches of wood. You'd have to burn an entire lamination away to get to the first bond line. So the fire working group that Sean was talking about, that he was a part of for the ad hoc committee, said, listen, we have to do a fire test. and there was no standing test for something like this. So the purpose of the testing was to evaluate, occupant escape tenability and firefighter suppression tenability, and to inform other standards. So this was the floor plan for the test structure that the work group came up with. It simulates a one-bedroom apartment. It's 30 by 30 feet interior dimensions. It has UL modern furnishings. So I don't know if you've ever seen that, the burn test UL does, where they have the side-by-side between modern furnishings and legacy furnishings. It's what Sean's going to show it. It's amazing. Not to bury the lead, but the legacy furnishings probably last 26, 27 minutes to flash over, where the modern furnishings is more like 3 minutes. So the modern furnishing fuel load imposed was 570 megajoules per meter squared. In English, that's equivalent to the same amount of energy you would get from 300 or 400 gallons of gasoline. You have a 20-minute rated door between the compartment and the corridor, and a 90-minute door on the corridor to the stairwell, which is exactly what the code requires. The ceiling height was 9 feet. This used a 5-ply CLT that was a Douglas fir larch species. It was about a little less than 7 inches thick. It had a wraparound corridor and a stairwell, and he loaded the ceiling to 20 PSF. So here are the 5 tests. The first is the baseline test. This is where all of the CLT is covered with 2 layers of 5/8 Type X gypsum wallboard. For those who don't know, Type X gypsum wallboard is the fire-rated wallboard. Test 2, they exposed 30% of the ceilings in the living room and the bedroom. Now, the original intent was not to expose any of it, but the design community said, hey, wait, we have this great-looking wood and we can't expose any of it, so they decided to test it. Test 3 had 2 opposing walls that were exposed. Now, test 1, 2, and 3, there is no fire suppression. There is no sprinkler system activation. It simulates the unlikely scenario that there's a fire, the sprinkler system fails, and the fire department doesn't show up. Test 4, which is to be the most realistic, has a normal sprinkler activation, but it has all the mass timber exposed and the doors open. Test 5 simulates a sprinkler failure, a fire department response that would charge the sprinkler system 20 minutes into the fire. So these are just still pictures you can see. Up in the upper left-hand corner, you see a framed out ceiling plenum. The one regulation with CLT buildings is there could be no concealed combustible spaces. Now, if you left that open, like in the lower left-hand corner, you don't have to cover it, you can expose it. But if it's in a concealed space, you have to put at least 1 layer of Type X 5/8 gypsum wallboard. And down here, you can see the fuel loading. And the fuel loading, it wasn't enough to get to that 570 megajoules per meter squared. They had to add wood cribbing, and they actually added a bunch of old code books, actually, and the people were more than happy to give up, by the way. This is the bedroom and the bath. You'll see more wood cribbing. And you see OSB floor here. That's to simulate a combustible floor. And like I said, test 1 has 2 layers of 5/8 gypsum wallboard. Okay, now all the fires start the same way. They start in a corner base cabinet in the kitchen. The pan of gasoline, the ATF firefighters come in and start it. Now, there was no glazing in front of those portal openings for test 1, 2, and 3. The engineer, this was actually at the ATF lab, supervised by the ATF staff and the USDA Forest Products Division lab staff. They wanted to leave it open because they wanted a high-intensity fire. They really wanted to put this type of construction through its paces. It wasn't really there to simulate actual real life, because in real life, sprinklers activate about 95% of the time, and fire departments actually show up and put the fire out. And people don't have 8-foot portal openings in the front of their apartments. But they wanted to see what it could take. So you approach flashover in the living room right around 13 minutes. Flashover for laboratory sense, I mean, when you're a firefighter, you look at it and go, oh, it flashed over. But for lab purposes, it is 600 degrees Celsius, 1 inch from the ceiling, which is about 1,100 or so degrees Fahrenheit. So you see it's going pretty good. They have the door open between the living room and the bedroom. Soon you're going to start to see the plastic start to melt away and the bed off-gassing. Now, the original plan called for glazing, as I said, and they were going to put appliances in the kitchen, but the appliances would not have contributed to the fuel load, and it would just be an extra expense, so they decided to forego that. However, they did run utilities, even though they didn't hook them up, and they ran utilities to try different methods of fire stopping to see the efficacy of fire stopping. And you're going to hear about fire stopping from UL Solutions after I'm finished talking. The one thing about fire stopping, I don't want to steal Wingoon's thunder, is when Sean and I visited the intro, Sean asked him about fire stopping. There's no listing for fire stopping. So the superintendent pointed to this big file cabinet and go, these are filled with engineering judgments about fire stopping. So that's a gap that needs to be filled, but you're going to hear about that later. So you're going to find out to the left is the 20-minute door. And the 20-minute door actually hangs in there a lot more than 20 minutes. How many people have heard that doze before you close UL thing? How long a unrated hollow core door will hold fire out? Well, this is a 20-minute door, and this thing hangs in there for over an hour before it fails. So you're going to see right around an hour, and there's absolutely no smoke intrusion into the hallway at this point. You already see the fire in the decay phase around an hour. Now, it's a 30 by 30 floor plan. The two rooms are separated by an unrated lightweight steel wall with unrated half-inch gypboard on it. That wall is completely consumed by the fire. So they terminate the test after about 3 hours. The fire had pretty much consumed all the contents of the room. These are just still pictures of the same fire. Now, if you look at the lower, the bedroom and the living room, this isn't even when the ATF firefighters overhauled or salvaged. That's how intense the fire was. It completely consumed all the contents of both rooms. That's how intense the fire was. Now, test 2, they exposed 30% of the ceiling. They actually put water barrels on top of the exposed section to see how it would fare when it's being burned. Same fuel load, same everything. And the fire starts the same exact way in test 2. These were especially intense fires. They reached up to 23 megawatts. To give you a perspective, if you're standing next to a really hot campfire that you're going to stand next to for about 5 minutes before you have to back away, that's about 400 kilowatts, 500 kilowatts. This is 50 times more intense than those. Only maybe 2 or 3 labs in the whole country could even have a fire that is this intense. So they really did put it through its paces. And for those who don't know about 5/8 Type X gypsum wall board, every board gives you 40 minutes of fire resistance. And that's important when it comes to mass timber buildings. They rely on that non-combustible protection. So in this case, the ceiling is exposed, and the ceiling will char, which is expected. In fact, it's the charring of wood that helps build in the fire resistance. The way it works is the outer layer chars and insulates the inner wood. Now, where that system can break down, especially when it comes to CLT, is if that first lamination burns away or delaminates. And Sean's going to talk about some early testing. This was only the second generation of testing. Sean's going to talk about the first generation of testing where the CLT did not fare well. It charred, it delaminated, exposed more fresh wood, which charred and delaminated until failure. It's a catastrophic cycle to failure. So in the second testing, they had to configure it so the CLT would not delaminate because it would take away its fire resistance. So once again, you have flashover at about the 13-minute mark in the living room, about 17 minutes in the bedroom, pretty consistent with the first. Now you see it's total flashover in both areas. Once again, that 20-minute door holds in there for more than 20 minutes. I actually asked a fire door manufacturer about that. And he said a lot of times if we're running, say, hour doors or 2-hour doors, and someone puts order in for 20-minute doors, we're not going to retool the line for a couple doors. So we'll just run an hour door or 2-hour door and just slap a 20-minute label on it. So I don't know if that happened here or it just held out longer than need be. So the fire is free burning at this point. The door is holding up. You see some tripods in some of the pictures, and you'll see thermocouples. They collected 420 channels of data for each one of these fires. And the tripods are basically deluge valves because ATF didn't want this fire to burn away their hood system or their calorimeter. So at 41 minutes, you see the fire's in a decay phase. And this will go pretty much the same as the first fire did. And then they'll terminate the test at 3 hours. And by the time they said the door fails, around an hour, the fire is well into the decay phase. So they pull all the gypboard off after this fire. You can see over the construction worker's head is a rectangle. That's where the ceiling was exposed. You can see sharp lines of demarcation where the 2 layers of gypboard was. You see some smoke staining along that glue lamb beam on the corners. And that informs a future code requirement where you have to stagger the gypboard. You can't have all the joints line up, and they have to be sealed. Because the last thing you want is for fire and hot gases to get behind the gypboard. And because those seams were all in alignment, they weren't stair-stepped or staggered, then you got the smoke staining. Now, this is a cross-section of that roof. And you can see, I'm going to walk over here for a second. You can see exactly where the gypboard ended. And remember I told you it was a 5-ply CLT, 5 laminations. Count from the top down, 1, 2, 3, 4. So it burned to termination, and it didn't even get to the first bond line of the first lamination of CLT. Now, I'm not going to go into these graphs. I just want to show you that these fires can be modeled. You can fire model CLT, building fires. The blue line is the actual data collected. The black line is the fire modeling that the Research Institute of Sweden did a month before. So those lines up pretty well. And in fact, since then, the RISE, Research Institute of Sweden, has refined their modeling process to make it even more accurate. Test 3, I'm not going to show the video for the sake of time, but it was 2 opposing walls. These are just stills from that test. You had the opposing walls, they charred as would be expected, and the fire went almost identical. The only thing different between test 1 and 2 and test 3 is that the fire door on the car door was installed improperly. So instead of it lasting 20 minutes, it only lasted about 17 minutes, which let fire and smoke into the hallway, but did not really affect the hallway tenability because it was already sort of in the decay phase. This is test 4, and this is the most normal, I think, fire. This will be the most usual circumstance. It has a working sprinkler system. They put glazing in the front of this. I only show this, it's anticlimactic. It only test lasts less than 3 minutes, but I don't know if any of you guys know Shane Ray from the National Fire Sprinkler Association. He didn't like that I didn't show this test because he wanted to show everybody how great the sprinklers were. So I put it in there. And there's the tripod deluge valves. But you see all of the CLT is exposed. And when I say all is exposed, you can never expose all of it because you cannot expose wood in kitchens and bathrooms. It has nothing to do with fire resistance, it has to do with hygienics. And you're always going to protect the shafts with gypsum wallboard. So you're never going to have fully exposed. But when it comes to walls and ceilings, that's what I mean by fully exposed. This test actually would have been over quicker if we just had a couch on fire because we had to wait till the fire broke out of the base cabinet to get enough heat to the sprinkler head to activate the sprinkler head. And all of the requirements for mass timber buildings require a full 13 system. You cannot have a 13R system. You have to have a full 13 system, and that's what this test has, a full 13 system, or simulates a full 13 system. So it busts out around 2 minutes, 40 seconds, and you see that the sprinkler douses it pretty quickly. And the sum total damage for this whole fire is right at the point of origin in that base cabinet. It doesn't get beyond that. So everything activated normally. Now, when it comes to this fire, this is simulating a sprinkler failure with the fire department response after 20 minutes. And in fact, they waited 23 minutes to activate the sprinkler system. What it's really doing is it's saying, hey, if a fire gets a 23 or 20-minute head start, can it overcome the sprinkler system? So this also has glazing. And it's actually kind of funny because around the 14-minute mark, one of the ATF firefighters gets frustrated with the lack of progression in the fire and actually bangs out one of the glass panels to give it some oxygen. so it'll burn quicker. All the CLT is exposed. They left the door open between the corridor and the unit and between the two rooms. The doors are completely open. So in this test, you start to see flashover in the living room, and it actually will make it to flashover before the sprinkler is activated. And then it almost reaches flashover in the bedroom. And right around 23 minutes, you're going to see them charge the sprinkler system. And there you go. They charge the sprinkler system, and about 7 heads activate and completely extinguish the fire. And this is just the after effect of it. So this is just an event log. If you see flashover in the living room, right around 13 minutes, between 12 and 13 minutes consistently, even more consistently, and flashover in the bedroom, which goes to show you that flashover is a product of contents, not building construction. It didn't matter how much CLT was exposed. It wouldn't matter if this was a concrete building. It's the contents were consistent, so the flashover times were consistent. Now, the only inconsistency is the door frame insulation failure, which let flames and smoke into the hallway and caused the door to fail quicker than in the other test. Now, I'm going to go over the 3 types. This is the first time in the history of the modern building code that 3 new types of construction have been added: Type 4A, Type 4B, and Type 4C. The tallest is Type 4A. This can go as high as 270 stories per the code. I told you that the ascent in Milwaukee is 284 feet, which is 4 feet higher than the tallest wood building in the world, which is in Norway with a name I can't pronounce. You can go as high as 18 stories with most use groups except for H's. All the mass timber has to have 3 layers of Type X 5/8 gypsum wallboard. Now, the test only used 2 layers. But they added an extra layer and has to be fully protected. Yes, it has to have sprinklers for 13 full 13 system. Now, the primary frame and the floor have to have 3 hours of fire resistance rating. Now, that is equivalent to what a Type 1 building, a non-combustible building, has to have 3 hours of fire resistance as well. Now, 120 of those minutes have to come from the gypsum wallboard. Remember, I told you you get 40 minutes for each board, so 20, 40, 80, 120, the 3 boards. The stair tower has to be non-combustible. It says to be a CMU tower, has to be non-combustible. In fact, around the country, I've toured like 3 or 4 of these type of buildings. They're all hybrids. You hardly ever see, and I've never seen a full mass timber building without some concrete or steel in it. And you have to have a floor topping of 1-inch non-combustible gypcrete or concrete. Now, Type 4B can go as high as 180 feet, 12 stories. You can partially expose mass timber, I think 40% on the wall. Under the 2021, it's 30% of the ceiling. Under the 24 IBC, you can expose 100% of the ceiling now. 2 hours of fire resistance rating for the frame and floor, 80 minutes of non-combustible protection. So that's 2 boards, 2 5/8 Type X gypsum wallboard. You can have a mass timber stair tower, but it has to be protected with gypsum wallboard, and you have to have the non-combustible floor topping. Now, Type 4C, you can go as high as 85 feet. You can go 9 stories. I don't know how you fit 9 stories in 85 feet, but if you figure it out, you can do it. Has to be fully sprinklered, 13, 2 hours fire resistance rating. Now, all that fire resistance rating has to be from the wood, so you have to upsize all the panels because you don't have gypsum wallboard to protect it to give it any fire resistance rating. And you can have, you're not required to have any combustible floor topping, but you have to meet all the standards of Section 804 in the IBC. Now, with old heavy timber, it's now called Type 4 HT. It used to be just Type 4. Now it's Type 4 HT. Stands for heavy timber. Now, that was the second generation of testing. The third generation of testing was at the Research Institute of Sweden. They used PRG 320 compliant CLT. I told you in the test that Sean's going to talk about, they did not have that standard at the time. They added this standard, which means it has to be tested large scale and small scale, and the fire has to decay over the period of 4 hours without any fire regrowth, no delamination. So they wanted to see how much, the primary objective was to see how much can you safely expose. That was the primary. They had some secondary research sort of results, but the primary one to see how much you could safely expose. But under secondary, they wanted to test connections and how to protect those, record facade exposures, predictive modeling, and a case study for restoring CLT after a fire. And the one thing I forgot to say about type 4 A, B, and C is you cannot have any combustible cladding. It has to be nothing combustible outboard of the CLT, because a little fire called Grenfell Towers happened during the deliberations, and that's why. And am I stealing your thunder, Sean? So Sean's going to go over some of the code requirements. So the way they did it was they had 5 compartment tests, and everyone had 100% of the ceiling exposed. But they had different configurations with the chipboard inside, and the chipboard is represented by red. So what they did was they fire modeled, they burned the first compartment, the steering committee talked about how they would configure it, and they burned the next compartment. So with test 1, 2, 4, and 5, they met that PRG 320 standard of the fire decaying over a period of 4 hours. And to go back, the other thing is test 4 was different than the other tests because of the opening factors. The opening factors for 1, 2, 3, and 5 were a residential opening factor. Test 4 was a commercial opening factor. So test 4 actually went out quicker than any of them because it had larger ventilation openings and could release the heat quicker. Test 1, 2, and 5 performed well. Test 3 did not meet the criteria for the test. And the reason it didn't meet the criteria for the test was it had fire regrowth. It didn't decay steadily. It still performed better than the test in America, but it had fire regrowth, so it failed the parameter, even though it would probably be okay for most applications. And the difference between test 3 and the other test, it had 2 exposed walls intersecting with an exposed ceiling, and that seemed to cause more damage. This is just a char depth, and I put in there the NDS char depth line for 2 hours of fire resistance. NDS is the National Design Specifications for Wood Construction, and even test 3 that didn't do well still was under that NDS char line. Now this is char depth. Imagine you're standing looking up at the ceiling. So the numbers to your far left and far right would be floor level, and then the numbers that intersect with that line would be ceiling and wall intersections. And they're the char depth rates in millimeters. And the thing that's antithetical about it is that we're taught, and it's true, fire burns up, heat rises, you would expect the char depths to be higher at the highest levels. When it wasn't, it was highest at the lower levels, and they believe it's because of the fire pushed oxygen down to the lower levels, and that's where it burned more intense. Now, we also tested intersections, okay? Now, they found out you have to account for geometrical anomalies. And in this particular one, this is why you have to seal the CLT. In this test, you can see, and I'll walk over here and talk louder, there is just a small gap between the CLT wall and the CLT ceiling, okay? And when I was in Milwaukee touring the ascent and the intro in Cleveland, they said the tolerances are in the millimeters. You do not get a lot of wiggle room when it comes to CLT and putting it together. So you had hot air and gas escape as represented by this picture, and you can't have it get behind the CLT like that. So they just put simple acoustical tape, it's not even fire rated or anything, over the gaps to account for any of the tolerances that weren't met. And they burned it, and none of it got through. So you didn't even need any special, it was just regular acoustical tape. Okay, now I'm going to tell you about, I get the question all the time, what happens if it burns? And the Research Institute of Sweden, after the tests were finished, took a piece of the CLT ceiling and sought to rehabilitate it. Now, is this the only way to do that? No. In any time you have damage done to a structure, you're always going to bring an engineer in. They're going to look at it, and they're going to give an engineered judgment on how to best repair it. So here they take the ceiling and bring it into the lab. So first they need to determine the char depth. So they measure it. Then once they measure it, they have to come up with a plan on how they're going to replace it. And how they replace it is they take glue lam on its side and screw glue it to the existing wood. But first, you have to scrape out the char layer. You have to plane it. You have to scrape it. You have to get all that char layer out of there. Like I said, in any situation, you're going to bring an engineer in to look and tell you what you need to do. And like a concrete parking garage, I've had car fires where the concrete spalled, exposed rebar. You bring in an engineer, and he tells you how to patch it, or she tells you how to patch it. No different than that. This is just one way to do it. SmartLam has another way to do it too. So here they glue the glue lam on its side. They screw glue it in to the existing CLT. And the one thing that people find interesting is once the adhesive cures, they take the screws out. And people go, why do they take the screws out? Because you don't want metal conducting heat to the inner portions of the wood. It is actually stronger and it is more fire resistant without the screws in it. And then once they do that cures and they pull the screws out, they just put a veneer over it just for looks. The veneer has no other purpose than to make it look decent. So then they take it and they actually tested it. And when they tested it, they found out that the flexural stiffness and bending capacity was unchanged. However, the shear capacity was reduced, even though it was okay for most applications. So if you had a short span with the high shear force, this probably wouldn't be a good idea. But for almost all applications, it is useful. This is the last thing. This was a test conducted in Japan, and it has it's like 7 stories, and they simulate a 6.2 and a 7. I mean, a 6.8 and a 7.2 earthquake. And CLT performs very well under these conditions because it bends. It's not rigid, and it doesn't look like they're shaking it that hard. But when they show you interior shots, you can see where they really, really shake the heck out of it. The DOD also did blast testing on it because they built base housing at Redstone Arsenal in Huntsville, Alabama. And the DOD, you have to have a certain blast rating to build for base housing. I don't include that test because, believe me, if you need to know if you can withstand a blast, you probably should build in a different neighborhood or something. But it does exist. If you look up DOD blast testing of cross-laminated timber, it'll pop up. So they give it a good shake. And it turns out pretty well. They've actually done, I don't think seismic is too much of an issue here, but on the West Coast, it's a real big deal. So thank you for listening. If you have any questions, you can ask during the panel discussion, and I'll turn it back over to Sean.
Thank you, Ray. And fair shot there. It's like keep between me and the microphone or Ray and the buffet bar, but don't give me the last word. But a couple of quick announcements as I turn it over to Young Gun. I've got a few questions on certificates. If you registered, you will receive a certificate via email. If you have not registered, don't worry, we can still get you in. Just see Phil tomorrow, and we'll sign you up so we can get your email. But the certificates will be emailed to you. And also, Phil has the Rock Hall passes. He's the, candy man today with all the goodies. So if you're interested in coming back to the Rock Hall, I know we have full days. They're good for 1 year.
I'd like to know, we're an ICC preferred provider, so if you have any ICC certs, they can get full credit for.
Oh, okay. And if you need ICC certs, let Ray know because he can give you a certification for watching his presentation. So, which gets us to the fire stopping testing. As Ray was talking about, when we walked through the building, simply asked the superintendent, "What are you doing about fire stopping?" He's like, "I have 2 drawers or 2 cabinets full of EJs," and those are engineering judgments. And basically, are you going to explain engineering judgments? No. Okay, so basically, an engineering judgment is a contractor will hire an engineer to evaluate that installation, and they use known test data based on those materials, and they make an engineering judgment based on their professional opinion, whether that would sufficiently perform as designed. So if it's a 2-hour rated wall or a 3-hour rated wall, what that engineer has to do is look at previous testing associated with that type of fire stopping, those types of materials, and make a professional judgment whether that installation will meet that 2 or 3 hour performance criteria. It's not our preferred methodology of approaching fire resistance. It's not really industry's preferred method, but really sometimes it's the only way to meet a particular design strategy. So when I was at UL, we really wanted to try to overcome that and really brought industry together with the testing group at UL to try to develop a strategy to standardize the testing approach that would be cost effective for the industry, but also effective for us in the fire service looking to get listed systems. So we have Young Gun here to talk about what UL's done in the way of research with fire stopping. Thank you, my friend.
Thank you.
Good to have you.
Thank you very much. Good morning, everyone. Good morning. So as Sean mentioned, I would like to hear in this presentation, I want to talk about the fire stopping material. Yeah. So my name is Younggun Yu. I'm a lead R&D engineer at UL Solutions. So before I want to talk about this one, I really appreciate inviting me here. I'm always dealing with fire in a lab, but here I have a great opportunity to meet the firefighters who deal with real fires, so that it was very great for me to get the perspective, and I really appreciate this chance. So in this presentation, I want to talk about the concept of fire stop and also how we test. I think it is very important to understand how we test fire stopping, and it is very important for firefighters to understand the standard testing, even though the standard testing is very different than real fire. But if you understand the standard testing, then you would expect what would happen, and you can estimate what a single fire stopping perform in a real case. So I want to talk about the standard fire stopping testing, and also some challenges of the fire stopping when we apply that in CLT. And lastly, I want to talk about the research project that we are doing, and also lastly, I want to talk about the UL's directory about the listed fire stopping. So first, let's start with the fire stopping. So this is a floor ceiling system. It can be wall, and this is a CLT, closed laminate timber, but it can be any materials. So usually, as Sean mentioned, when we have a compartment, based on the types of building, 1 hour rating, 2 hour ratings, which means in the standard testing process, like UL 263 or ASTM E119, a floor ceiling or wall should resist 1 hour or 2 hours. But when they test it, they only test with just pure floor ceiling like that, without any this hole. But usually in a real building, there is a hole like that to get the penetration. Here, pipe, it can be the wires and duct. So the problem of that is in the annular space, there is opening. So it is very important to seal the gap. So that is a fire stopping, as you know well. So it is very important to test, because to test the fire stopping based on the same test that we do in fire rating test for wall or floor ceiling. So UL 1479 is the standard test to test fire stopping materials. So I want to talk about, the through penetration fire stop system that consists of 3 items. First, fire rated wall, it can be floor ceiling, and also penetrating item and sealing materials, that is fire stopping materials. So as we do in fire rating in UL 263 or ASTM E119, that is time temperature curve that we use, as a furnace temperature. And that is just representation of the post-flashover fire condition. And when through penetration fire stopping system is exposed that time temperature curve, it endures 1 hour or 2 hours. And that is the condition of the standard testing. And also I want to briefly talk about several other conditions that we test. And pressure is also important. When fire stopping has sometimes it can burn, and when it has a melting, so there it would have a gap. And through that gap, so if the pressure condition is, the positive pressure occurs inside the furnace, the hot air or flame can go through, so that in a real test, we try to have the positive pressure condition at the level of the fire stopping area. Also, the individual ends of the penetrating item should be covered on the exposed side. And so now I want to talk about acceptance criteria. The main acceptance criteria is temperature. On exposed surface temperature, we put the thermocouples so that we measure the surface temperature and the temperature of the penetrating item too. So the criteria is a 325 degree Fahrenheit plus ambient. It reached, then that can be the time of the fire rating of this material. So also the passage of flame, if the flame can go through that opening, and if the flame can see the other side, then it also failed, and that is the time that it has a rating. Also, this wall should withstand the hot stream test. So these are the 3 main acceptance criteria that we used to test fire stopping for CLT. And now I want to talk about the rating. There are 2 main rating systems. The first one is F rating. So in F rating, if the flame go through the penetrating items, that is fail, and also if we failed by hot stream test, it also fail. That is F rating. But also we have a T rating. In addition to these 2 failure criteria, temperature is also the criteria. That is a T rating. So International Building Code does not require T rating for a wall, only the F rating. So there is F rating and T rating. So I think I goes really fast. So yeah, I want to talk about the challenges of fire stop in CLT. Usually in the traditional wall or floor ceiling system, usually we have a gypsum board or concrete, so that it is non-combustible materials. But CLT is a combustible materials, so that the main challenge of fire stop in CLT is the CLT, when it is heated, it paralyzed, and also it charred, as Ray mentioned. And that's one important behavior, because that charring might affect the fire stop, the seal integrity. And also, one of the most important thing is about the different species. As you know, there are many different species in the world. But PRG 320, which the building, the species, PRG 320 specified 14 different types of CLT. And as you know, but there are many, in that category, there are many different species, and they have different charring behaviors. Some char really quickly, and some char really slowly. So it is very important to understand how charring behavior of each different species affect the fire stopping performance. So the research project that we are doing at UL is, the main goal is to find the most representative CLT species for stopping testing. For now, when you test fire stopping with specific CLT type, UL category, UL directory specify that species like E1, like E2, like that. So we want to find the most representative CLT, then we can apply that species for all species. That's our goal. For that, we did a literature review, so that we conducted a literature review to find different species, CLT species charting behavior and what could be the challenge of the fire stopping in CLT. So we complete that part, and based on the literature review that we did in CLT, we found we selected 5 different species. So Douglas fir, spruce, yellow southern pine, and balsam, and also poplar. So with that species, as you can see, this is cone calorimeters. The reason why we choose cone calorimeters is small, but we can understand each charting behavior with a very specific heat flux condition. So we chose 50 kilowatt per square meters, and we tested, and that we also done with that. And I will not talk about the very detail about the result, but the thing is, based on the results, the most charred material was poplar, and most least charred material was Douglas fir. So we would use Douglas fir as a reference, and poplar is kind of the least performance materials. And based on these 2 selection, we will test real scale UL 1479 test. So based on that, we want to know how different species charting behavior affect the fire stopping material. We're done. So now I want to talk about the UL listing systems. And now currently we have 6 listed fire stopping material for CLT, and FG1000, FG2001, FG3001, FG5001, but we have 2 more, FG2002, FG2003. So F means floor, and G means CLT floor. So 1000, the order of 1000 is metallic pipe, and 2000 is non-metallic pipe, which is plastic like that, conduit or tubing or plastic, and 3000 is electrical cable, and 5000 in insulated pipe. As I said, we have currently 6 listed fire stopping material in our directory, and all of them is from Hilti. So, and as I said, when we test these 6 systems, we all use just E1 Douglas fir larch. We use that specific CLT grade because we do not have more knowledge about how different species would affect the real fire stopping materials. That the only way that currently we can do is just test with the specific CLT and list with the CLT, with that specific CLT in the directory, so that future user can use that data. But I hope that we can find the most representative CLT, and if the fire stopping material test with that CLT, they can use for other CLT species. That's our goal. So lastly, I want to talk about the product IQ, which is a directory of our UL's fire stopping system. So if you Google it, UL product IQ, then you can find this web. Also, there's many information about fire stopping systems and also cross-laminated floor assembly. If you put that in keyword over there, then you can find the fire stopping and CLT, and you can find the 6 CLT fire stopping, listed fire stopping system. And for the future, we will keep updating, absolutely, so that please check on that. Thank you very much. That's all what I have.
Thank you, Youngun, and yes, work continues. I think everyone could use a break for the next presentation. So what we'll do is we'll break for 15. If you come back at 25 till, then we'll have the next presentation and go right into the panel discussion. Please get your questions ready for the panel discussion, and appreciate it. See you in 15. after Young Gun. What's that? Can go? Okay. Okay, folks, we're going to get moving. I just looked at my watch and we had a 20-minute break, so, but that's okay. So wait for the slides to come up. All right, so we had a presentation. Ray started talking. Ray went over a lot of the testing that we did. And as Ray mentioned, there is the ad hoc committee. I'll get to that in a minute. But this was an issue that really came up. We were at a code hearing in Long Beach, California. It was at that time, what they called the public action or final action meeting. And that's where jurisdictional representatives vote, yay or nay, on the various code change proposals through the ICC. And there was a code change proposal that was being propagated forward by the American Wood Council. And as Ray mentioned, at heavy timber, we were limited to 6 stories. But this code change proposal was going to allow up to 12 stories. And from a fire service perspective, we didn't think they had any validation. There was no research cited. The thing that was really cited was this would benefit or reduce the impact of wildfires. And if you go online, you can find conflicting reports, whether the increasing of mass timber will reduce the impact of wildfires. It's subject to debate. But from a fire service perspective, we said, well, wait a minute, you're doubling the size of a permitted type of construction with no validation through research. So it was basically myself and Mike O'Brien from Brighton, Michigan, that went to the microphone and started challenging the industry. And they had a lot of high-paid individuals that were representing them. But we were successful in stopping that code change proposal. But that led to what Ray was talking about, the establishment by the International Code Council of an ad hoc committee to look at this issue. And really the charge for the ad hoc committee was to review current data that is out there or current research and propagate forward any potential code change proposals related to mass timber. During our discussions, discussion started at 44 stories from some people. And we had a number of fire service representatives on the committee, which was very fortunate. So we could really start to drive the discussion. And during that discussion, it was identified that we did indeed need research. And the ICC and the American Wood Council went to the U.S. Department of Forestry and sought money from the Department of Forestry to conduct testing. And that testing was done by the National Research Council of Canada and done at the ATF lab in Maryland. And Ray went through those. But this kind of just popped up on our radar. And what we have to keep in mind is from a fire service perspective, when we start talking mass timber, we see the amount of fuel that's there, that the fuel load is significant. And immediately our minds start to jump. Holy crap, that's going to be a heck of a fire, right? But we also have to keep in mind that mass timber is a very different product than dimensional lumber. And over recent years, I would say the last 10 years specifically, we've seen significant fires in buildings under construction involving dimensional lumber. In fact, just last week, there was one out in California. And a friend of mine, Robert Marshall, said, we just went to 10 alarms. And Ian Hardage jumped in and said, I didn't think we had 10 alarm resources in the county. He goes, we don't. So it was a building under construction using dimensional lumber. And it was a witnessed ignition by the workers on site. And they called 911. The fire department response was very rapid. But even a 3-minute response time, that fire is out of control, because when you look at the mass of wood that you have to the exposed surface of that wood, that fire moves very, very rapidly. And what we wanted to do in the mass timber is really validate, okay, how is this fire going to perform under fire conditions? And so this is not new. Mass timber was introduced into the marketplace in the 1980s. We actually have numerous buildings that are out there that are made of mass timber. Ray mentioned a couple of them over in Sweden or Austria. This is a site, or this is a project that was being built in New Zealand. From the exterior, it doesn't look like mass timber, but it is. Same here. This is also a structure that was built in New Zealand. Does it look like mass timber from the exterior? And the answer is no. That exterior covering hides that mass timber. And but the commonality out of all of these is it's low rise. So it really didn't get on our radar. But the code change proposal in Long Beach was starting to go, no, we're going to go higher. We're going to start to go to a high rise specification. So that really did start to raise some of the concerns that we had from the fire service. And you see the various projects that have been built or are being proposed to be built internationally. This really became an issue for us. And you have to remember that there are various forces that are kind of driving this. And we talked about those influencing forces bringing technology or new building tech practices to the market or materials. With mass timber, there are various interests. Some are looking at storing carbon, so to help with global warming or the contributions of carbon to the atmosphere. Some are looking at reducing the impact of wildland fires. That's debatable. Are they harvesting these trees from areas that are experiencing the wildfires? Some are looking at simply to promote the timber industry. And our funding to do the testing came from the U.S. Department of Forestry and the Department of Agriculture, because they're looking to increase the use of timber, again, for various factors, right? Some argue that it's a renewable building material. You cut down a tree, you plant a new one. It's renewable. So there are various influences that are driving this. And like I said, some just want to increase the job market in the timber industry. And that doesn't matter, really. We have various interests for all kinds of initiatives that we take, whether it's business-wise or personal-wise. That doesn't matter. From a fire service perspective, we want to make sure it's safe. We want to make sure it's safe for the occupants. We want to make sure it's safe for when we respond and operate in. And that's the approach that we brought to this effort. And, when we were early into this, we had those proponents, especially from the wood industry, because they certainly don't want a bad incident involving CLT. This isn't a cheaper type of material. I really have to say that. Ray and I were talking about, it's not cheaper to build a building out of mass timber. It's actually more expensive right now. So, what is your driving factor? What's your goal? Is it to be that innovator or to build green or to build with renewable products? That's fine. And so you're investing in that. But when you saw some folks that were proponents from the industry, they're saying, well, we're going to fully protect this. They'll say it in Canada, we're fully encapsulating it. Or we'll say we're protecting it. But when you go into the design community, this is start to what you see. The architects, the designers, they want that freedom to be able to use that inner wood surface for the visual and aesthetic look. And we saw this fully exposed, high rise. So we just had a disconnect there. And that's really what the ad hoc committee had to work through. And because when we start to look at the modern fire environment, Ray mentioned this. I don't know if all of you have seen this video. We redid it at UL FSRI. Basically, on the left, you have your natural room. That's natural fibers. That's solid wood framing. That is cotton batting. That is a natural fabric. When you wore out the fabric on this couch, you reupholstered it. And the only thing that's missing is the plastic cover that grandma would have on it, right? On the right, you have a synthetic-based product. It's pressboard construction. It's polyurethane foam. It's a synthetic fabric. And you see initially you have open flaming on the left because it's fully consuming that natural product. And this does have flame retardants in it. It's a product brought off the market. So once that fire takes hold, you can see the dripping piles of goo in the back. That polyurethane melts, that flame retardant off gases, and then you're dealing with the fuel. And you look at the difference in the byproducts. What's different on the right? That thick black smoke that's being produced. If you think about our home construction now, we have wide open spaces, especially on the first floor, right? Socializing. So now you have that rapid buildup. You see the off-gassing, the preheating there, and we transition the flash over in 4 minutes and 50 seconds. In the previous video, it was 3 minutes and 52 seconds. So there are different influences, especially of ventilation and the size of the opening. But we go to the natural room, and you see at 30 minutes, we have not reached flash over. If I made a wider opening, we would not reach flash over at all. And why is that? Because you're allowing the heat to escape. So you don't have that re-radiant heat coming back down onto the combustibles, which helps drive it to flash over sooner. Russ Sanders, who worked for NFPA for, I think, 80 years, and also for Louisville Fire, you know, he got on with Tom back in 18 something. Russ would tell us, I don't recall ever going to a fire that flashed over before I got there, right? Because he was dealing with natural fibers. And in today's world, our firefighters can't say that. Most times when we arrive on the scene, that fire is flashed over, it's become ventilation limited. It still might be blowing out that window, but still could be ventilation limited. And I talk about the changing materials, right? In 2016, Dan Madrzykowski conducted 82 tests. He was looking at the impact of ventilation on interior fire spread. He was looking at researching the cause of the fires. And when you do 82 tests and you're looking at specifics and the influences, you have to have consistency, especially consistency in the fuel load. So Dan ordered furniture in bulk. And when we were putting it in the room, we noticed it was extremely light. So Dan took the fabric off the furniture, and this is what we have. We have the polyurethane foam, but it's not solid frame. It's not pressboard frame. It's rigid polystyrene frame furniture. And you wonder, why would they do that? Well, it's cheaper to build, but also shipping cost. If you reduce the weight of the furniture, if you're relying on, you can reduce cost in shipping. So again, we see that transition of the materials in the marketplace. And we don't even know about it. So this was an effort. The NFPA has the Fire Prevention Research Foundation. And it's a non-for-profit, and they're financed a lot by the insurance industry. And we found out about this project when it was already in stage 3 of phase 1. And that was during the literature review. And what they were trying to assess was the contribution of CLT to the fuel package so they could build a modeling profile, as Ray mentioned earlier. They had representatives from industry. They had representatives from the insurance industry. Who did they not have represented on that exercise? The fire service. No one was there. So we pushed, and we got 2 of us appointed to it, myself and a gentleman from Canada, from Regina, Canada. And what Ray was saying, we got involved very, very late. And so I want to point out what their goal was with this project. It was to measure the contribution of CLT. It was not to evaluate the structural performance of the CLT. Not that they weren't concerned about it, it just wasn't the goal of their effort. And they were conducting 6 tests, and this is a breakdown of the test. They do their baseline test with 3 layers of gypsum board, right? That's your baseline. The second test is they're going to have a ceiling exposed, and that was the 4th test, really. And we also, while they didn't add the hallway that we were able to add in the ICC because we wanted to see what conditions would be in the hallway, because that's where our members are going to be staging prior to making the initial attack. We wanted to see what those conditions were. They didn't add the hallway, but they did add a variance for the ventilation profile to account for a patio door, you know, different size patio doors that may fail during the exercise. So you see these are the tests, and after the first test, really, this is what happened on the interior. It was a room and contents fire. The contents based were the content fuel load that Ray shared, because in the ICC exercise, we followed this project very closely because we wanted to be able to use it as a comparable. Thank you. And so we used the fuel load that was designed in this, and it was based on a Zillow review. Thanks. It was based on an assessment, a report that came out of Canada that estimated what would be a typical fuel package in a residential occupancy. And we later found out that that review is based on a review of Zillow profiles. So those researchers were going through Zillow to see pictures of homes, and that's how they estimated the residential fuel package. Now, if you've ever sold a home or bought a home, what's the first thing the realtor tells you? Get rid of all this crap, right? Unclutter it up. So, but we wanted to be consistent. So, but with 3 layers of gypsum board, we expected this. We didn't expect anything. So the next test had 2 layers of gypsum board. 3 layers didn't have any effect. We felt we could go to 2 layers. or I should say that the test, Dr. Joseph Su felt we could go to 2 layers and have no issue. So we went to 2 layers, and after the test burned out, after the compartment fire, we went down into the lab, and this was done at the NIST lab in Maryland. And I noticed smoke coming out of from the top of wall joint. And I pointed out, I said, Joseph, is that supposed to be smoking? And he said, well, no. So we went in there, and the lab technicians took the gypsum board off. And what we found in that top corner was that the fire had gotten through the gypsum board to the top of wall joint. And we started asking Joseph, well, how can this be? You have a controlled environment. You have a test lab where your staff is trained. They understand what they're doing. You have a competent staff. What happened? He said, well, the staff did not seal the top of wall joint like they were supposed to. They also put the gypsum board, as Ray mentioned, the seams were inlined. So there was no overlapping of the layers of gypsum board. So that allowed the fire, once it got through the gypsum board, to get right to the top of wall joint. So I asked Joseph, I goes, let me get this straight. You had a controlled environment, you had a trained staff, and they screwed up. He goes, yes. I said, welcome to our world. That is the fire service. That's what we deal with. We have projects that are so well intended out there, but we're dealing with people. We're dealing with the 3 causes of fire. So really, and you have to keep this in mind, when you go through testing, when you go through research, this is not necessarily failure, right? This is why you're conducting research. If you fail to learn from it, that's failure. So when we were going through this process, we understood that the ICC was going into the ad hoc committee, that we wanted to learn from this, and we were going to build off that at the ICC process. We wanted to learn moving forward. And this is, I'll just show you because we need fire porn. I wanted to show you one of the tests. And again, it was a similar fuel package. It's the original fuel package. We started it in the kitchen, and you could see it's wood cribbing. And the wood cribbing is going to propagate over. As it builds, you'll see it moves across the ceiling. It's talking to you, Brian. So, yeah. And then you're going to see the mattress off-gassing. It's going to ignite. And we get a pretty good size fire. Whether it's based on a Zillow review or not, we have a pretty good fuel package there. And that's all the instrumentation there. We're protecting that instrumentation with the matting, the fireproof matting. 14,000 kilowatts in 12 and a half minutes. So you see the bubbling of the floor. So we felt we're stressing that room. In test 4, this was an exposed ceiling with the narrow opening. And what we recognized here, Ray kind of mentioned it, if you see in the left-hand side there, you see the bare spots of wood. So the CLT, Ray mentioned it, the CLT actually has an inherent fire resistance rating. It's based on the char rate, the calculated char rate that's been around since the 1960s. So they calculate how long that's going to take to be consumed. You can anticipate what the performance of that wood would be under fire conditions. What was happening here is that as that fire was being exposed on that wood, the glue, the adhesive, started to fail, which then started to cause that premature delamination into the room, which actually in these tests led to a secondary flashover into the room, which then led to further damage. This is the delamination you can see right there. You see large chunks, and as Ray said, once you start to lose that, now your timeline's out the window. Now, from a perspective of those that are organizing this test, they're looking at it as how they're going to calculate their model. We're looking at it as a structural performance. So you see here, all of a sudden you had a drop-off. When you look at test 6, you had a drop-off, and the reason you had a drop-off is you had a catastrophic collapse of that ceiling. Now, this isn't necessarily failure. This is an opportunity to learn. And we learned this going into the ICC, and I'll get that going. And this is the Brock Common Tower. This is an 18-story. It's anytime we go above 12 stories, you're going to see basically a combination type of construction. It's going to be structural steel. It's going to be some cement, and you're going to see the CLT panels that are involved in the walls and the floors and ceilings. And some of the inclusion of the cement on the floors actually is to achieve acoustical performance. so you get that sound barrier between the floors. So this is an ICC, a picture of the ICC. I think it was Free Beer Day, just looking at the number of people that are actually involved in the process. But, you know, you've heard us mention this. It's really important we're involved in this process. I mean, the codes actually establish your work environment. If I say I want to improve your work environment, what does that mean? I can ask Scotty, hey, I want to improve your work environment. Scotty can go, you know what? We need diesel exhaust systems on our apparatus floor, and that's great. And I can ask Bill, I go, hey, I want to improve your work environment. He goes, you know, we need PPE dedicated rooms with the exhaust right to the exterior. I said, that's great. And I can ask Super Dave, I go, I want to improve your work environment. Dave will go, I need that 80-inch plasma TV in my office so I can watch training videos. And that's all great, right? But am I improving your work environment? No, I'm improving your fire station. I'm improving your staging area. To improve our work environment or protect our work environment, we have to be involved in a process that establishes how that work environment is designed, built, and maintained, because our work environment are the buildings we respond to and operate in every single day. And that's established through the ICC process. So Ray mentioned it, we established this ad hoc work group. I'm trying to remember if we had 34 members to this group, I believe. It was a wide representation. We had folks from engineering, we had folks from building officials, we had folks from various industries, the wood industry, steel industry, concrete industry. We had representatives from the fire service, and we broke it down to 4 work groups: the fire work group, the structural performance work group, the standards and definitions, and the codes under the heightened area table. And I was fortunate enough to chair the fire work group, and I had a great partner in Jason Smart from the American Wood Council. Jason's an engineer, and he was able to take a lot of what we were trying to articulate from the fire service and put it into the test planning. We wanted to develop and perform tests of realistic fire scenarios applicable to tall wood construction. Really, we wanted to answer that question. Is this stuff going to come down on our head if we're operating in there, right? And what do we need to do to make sure that it doesn't? And the testing in Canada was very much on our mind because we saw that collapse. And we wanted to evaluate occupant and firefighter tenability for egress and suppression efforts. That's what led to the inclusion of that hallway in the ICC test that Ray pointed out. And also, we wanted to develop some data so we could educate our firefighters. Ray mentioned the various types of construction that were added. So, you know, we didn't want to do harm, I should say, to the code. And that's why the committee proposed to develop 3 new additional classifications under test 4. The building area, I'm not going to get into the calculations in here because, quite frankly, it's above my head, right? Tell me how big it is. Tell me how tall it is. But, you know, we had folks that really, really debated it. Steve DiGiovanni was actually our chair lead. Steve is out of Las Vegas. He's a fire protection engineer. But there was basis for the calculation for the allowable areas and heights, and I'll show you just a couple examples. And this is the stories. So it's broken down by occupancies. Chapter 5 of the ICC, the heightened area table. That was my baptism in the code development, was to be established on the heightened area ad hoc committee. And I didn't run away screaming after that. So, but this is just the residential aspect of it. And you can look, non-sprinklers not applicable here. Because one of the things that the committee said is, listen, if we're going to propagate this type of construction forward, it has to be sprinkler, right? We have to protect it. So you can see the different types of construction based on, as Ray said, the level of passive protection that's included allows you to go to greater heights. And as I mentioned, we started at 44 stories was the first proposal. And, you know, after I passed out and they woke me up, I went, what? Okay, let's be reasonable here. So we, as a committee, and we operated on consensus. And I will say, because I was at the microphone, from a fire service perspective, I did not agree going right to 18 stories. I thought we were being a little too aggressive, and the jury's out on that. But it was what the committee decided to do, and at the end of the day, it's what the ICC membership voted to accept. Because what we also have to keep in mind, and I want to throw this in, the reason this was critical and is a lot of our building officials were getting a lot of pressure to move green projects forward. And every one of these mass timber buildings were being approached in singularity. So they had their own designers had their own ideas on what they were going to include in protection. We were all over the place, and there was no consistency involved. And so, really, what we wanted to do through this process, we couldn't put our hands up and say to the steamroller, "Stop!" Right? We had to find a way forward to give consistency, so that the building that they're proposing in Cleveland will be meeting the same fire protection requirements in Seattle and likewise in New York. And so from a fire service and a building official perspective, and you'll hear from our Cleveland building official today during the panel discussion, it really provides them a level of consistency and also, what I want to say, reliability moving forward, that this has been, tested and they're not on a limb. And these are the high permitted areas. We went to some large areas like 432,000 square feet. I'm like, hell, during construction, that's a wildland fire, right? I don't know where the smoke jumper is going to land, but it's a big area. So during construction, we really had to be cognizant of some of the things. And I'm going to go start picking up here. And as Ray mentioned, when we were in our discussions as a committee, that's when Grenfell occurred. And if you're not familiar with Grenfell, George, did you cover Grenfell at all yesterday? George actually went over to Grenfell and walked through it with the London Fire Brigade. But it was a one-room fire. And the brigade got up there, was on the upper stories, knocked it down, and they thought they were done. Unfortunately, this fire pinged out the window and onto the aluminum panel on the exterior, these insulation panels that are simply thin pieces of aluminum, and they have a rigid polystyrene insulation. And if they're not built correctly, that adhesive can fail, that exposes the insulation, that insulation starts to melt, and it's off to the races. And also the interstitial space behind that facade was too large, so it allowed airflow, and it really allowed this fire to propagate. Over 80 people lost their lives. There are a lot of contributing factors. There was only one means of egress, and there's an effort right now to allow one single means of egress in 11 states. Ohio is one of them. There are being proposals for advocates for affordable housing to allow up to 6 stories in residential buildings to have a single stairwell. And the IFF, we're fighting back at it. We have a joint position statement with the Metro Chiefs and others. But let me get off track here. Back to the exterior walls. What the committee decided after the Grenfell is that none of these buildings over 40 stories can have any combustible materials in the facade. That doesn't mean the facade passes an E119 test, ASTM E119 test, and it's considered non-combustible. The committee agreed that even that facade cannot have any combustible materials included in the system. So they can't use this polystyrene foam inside those metal panels. Because this is not a protection option. This is actually a proposal for a building in China, but we don't think this is a fire protection strategy. The other thing that we learned from the Canada effort was the importance of inspection. We had trained crews in a sterile environment in the lab, and they still missed something. So what we included with the requirements in the code is special inspections throughout the process. Really, what attachments are you using? Are you using the screws or the connection that you said you were going to use in your design? Are they properly attached? Are they properly secured? Are you sealing the top of wall joints? Those are the things that have to be inspected by an independent inspector throughout the process. Water supply. If we're going to build tall timber buildings, we want to ensure that we have water supply. It is a combustible product. I don't care how you cut it, either which way, wood burns. Kuma still hasn't figured that out, but wood burns. That's a private joke between Ray and I. So in order to ensure that water supply, we went back to what we did in the codes after 9/11, because we know World Trade Center 7 collapsed from a contents fire. When the jet airliner impacted the towers, it did not damage Building 7. What it did is it damaged the water supply to Building 7. The fire ignited in Building 7, and that tower came down due to a contents fire. So we wanted to ensure what we did in the ICC for buildings over 420 feet. You have to have a redundancy of water supplies. It can't rely on the singular water supply. We brought that concept to here, In tall timber buildings over 120 feet, you have to have a redundancy of water supply. We want to make sure the firefighters have water if they have a fire on the 18th floor, if they have a fire on the 23rd floor or the 30th floor. The owner's responsibility, we went round and round, right? If we're going to say, okay, you can go to 18 stories because you're putting a non-combustible interior finish on there, you got to make sure it's maintained. And the response was, well, a man's castle is his home, or a home is his castle. We can't go and inspect residential properties. No. These are tall timber buildings. These all have homeowners associations. These people are signing a lease when they go in there with that homeowners association. You put in that lease, you have to meet the code. You have to allow the inspection of that interior property at least once a year. So again, if you're going to be reliant on that non-combustible protection, we want to ensure it remains in place. That, you don't remove the gypsum board to put up your Led Zeppelin poster up there. Vertical enclosures, Ray kind of hit on it, but we went discussing this. In buildings under 75 feet, the exit enclosures and elevator shafts require additional protection. Up to 0 to 75, I should say, no additional requirements. But 75 to 180 feet, they have to be fully encapsulated with gypsum board. If you go over 180 feet, they have to be a non-combustible construction, basically cinder block. Again, that's the means of egress for the occupants, but that's also our point of entry in our operations if we make entry into that tower, if we have a fire. We want that secured egress. Under construction, I haven't looked at this slide in a while. This was a lot of discussions that we had, because when is the building most vulnerable? When it's naked, under construction, when we don't have the protection in there. So we wanted to put requirements in there for all types of type 4, but also to put this back into the fire department's control too. Standpipes shall be provided during construction. We've seen way too many instances out there where buildings are under construction or renovation or deconstruction, where the standpipes have been compromised. If you look at the Deutsche Bank fire in New York, we had multiple firefighters killed in that fire because of the compromise of the standpipe system. So they have to be in place. Water supply as approved by the fire chief. And where building construction exceeds 6 stories above grade plane, once you get past that 6th story, you have to start installing exterior and interior gypsum board or non-combustible protection on those walls. So we really want to be aggressive in protecting these structures while they're under construction. And a lot of this was actually based on what they did in the Brock Commons Tower. Because when they proposed the Brock Commons Tower, they were really pushed for time. They had a time limit until approval. So as Ray mentioned, using alternative methods, they were really aggressive in some of the things they proposed for fire protection, such as at the end of every shift, they cleared out all combustibles on the job site so they didn't have a loose fire. And we coordinated a lot with what they were trying to do in Canada. So again, we could have consistency. This graph is just showing, okay, if I'm going to go to the 7th, I got to start putting the gypsum board or non-combustible on the interior or the exterior. And as Ray mentioned, that delamination was really a concern. And at some point, PRG 320 is an industry standard, and the ICC says we have no authority over it. And we had representatives from PRG 320 within our discussions, and they said, we don't think we have a problem. They said, well, the fire service said, well, then this isn't going anywhere. If we're going to have early delamination, we're not going to allow this. We're going to block it at the committee level, and if the committee tries to go forward, we're going to block it at the ICC level. And then the PRG 320 committee did what they were supposed to do, and they put this as a mandatory annex. And simply what they're doing is they're replicating the exposed ceiling in the Canada test. And the fire goes, I think it's a 4-hour test, right, Ray? It's a 4-hour test, and they start to measure the delamination and to see if they have fire propagation or, I should say, secondary flashover or any regrowth. Is it perfect? No, we know that. I don't think we can look at any section in the code and everybody can look at that and go, oh, that's perfect. But at the time, it's the best information that we had, and I think that we're doing a good job. I mean, what we realized is that the polyurethane glues had to be reformulated because they were dropping off. And the code says up to 18 stories, but heck, they hadn't even bought the ink and the paper yet to print the code book when Milwaukee was already moving forward with their tower, which is 25 stories. And how can they do that? Well, they can go to the local jurisdiction and apply for alternative methods. And if that local jurisdiction accepts their proposal, they can allow that project to move forward. And we're only limited by the human imagination. This is a project, River Beach, that has been proposed for Chicago. This was proposed a number of years ago. It hasn't moved forward, but you can see that exterior skeleton is made completely of wood. They're proposing it to go to 80 stories. And they're going to put combustible trees on the interior as well. And we actually were in a meeting, and John Cirillo from FDNY stood up. He said, "This is great, love concepts." He goes, "But I recall two buildings in New York that when they were built and designed, they were built to absorb the impact of an airliner of that day. They never imagined the airliner of the future." And so really what we need to do as we design these buildings, and it's okay to have imagination, you can't always just design for the hazards of today. You have to anticipate where the hazards will be for tomorrow, because these buildings can be long life. And that's not the only one. This is an 80-story tower that's been proposed in London, and I believe this one also has one single stairwell. We met in Tokyo with Sumitomo. Sumitomo is a forest company in Tokyo, in Japan. They are proposing a 350-meter structure to celebrate their 350th year as a company. I kind of chuckled. I go, "You've been around longer than our country." But they were like, "How do we do it?" I'm like, "I'm just a fireman." But, you know, will these designs come forward? I don't know. They still have to design the protection features for that. That's the Milwaukee project. But one thing to keep in mind,
20 pounds! 20 pounds on my left! 30 pounds! 20 on my right! 50 pounds! 50! 70! 90! 200 pounds! 200 pounds up there! Anyone else? Gone!
see, you're chuckling. You didn't hear the splat. So Aaron's like, "Oh my God, you're going to show that movie." And so it's a humorous movie. And I've been very, very fortunate. I've been very fortunate when I was on the Cleveland Fire Department as I connected with UL. George and I have been blessed to be able to present and travel internationally. And I was invited to present in Moscow. And actually, I think George is the one that warned me. He goes, "Watch out for your jokes. They don't always translate." I said, "Come on, it's visual, it's funny." Yeah, so there were about 1,500 people at this conference, and I was presenting on codes and standards in the US, and I showed this video, and everyone has translators on, and the video ends, and I kind of turn around, I smile, and dead silence. And I'm like, "Ooh, crap, So I just kind of moved on and finished up, and I went back to the table, and Kevin Fulton from UL was sitting there, and Kevin's chuckling. He goes, "I think they think that's real, that you guys charge to save people in that capitalistic society." And I'm like, holy crap, he's probably right. But the point of showing the video is, and I go back to that single stairwell proponents, right? Because they say, well, the fire department can rescue people with ladders and aerials if they get trapped. Anytime we put up a ladder, anytime we put up an aerial to rescue an occupant, that's a failure. It's a failure of the system. It's a failure of the system to design that building properly. It's a failure on our part because that system wasn't maintained properly, right? Because we are responsible for that inspection. Anytime we put up that ladder or aerial, it's a high hazard operation, even for our trained firefighters. So we can't expect the public to be able to exit the building on a ladder or an aerial without increased risk. So that's why it's important that our buildings are designed, built, and maintained appropriately and properly. And so that's why I show the video, because the goal is not to put any more names on here. This memorial is right down the street, right by the Brown Stadium. It has 77 names of our members here, 78 names now with Johnny being added to it. So we don't want to add more to it. Can't always prevent it, but we can do our best not to. And that's the goal of being involved in these processes. And that's the goal of trying to bring this information to you. So thank you very much. We're going to go ahead and move to the panel discussion. Jimmy, Tom, if you guys want to come up as well. Young Gun, Ray. We got the great oak tree right here. That's you? Thank you. Okay. Gotta get 2 more mics. There you go. And that was the goal, is to get you on stage at the Rock Hall. Your rock and roll superstar fantasy has come true. That's okay. Tom Flam just kind of wanders around singing old rock songs throughout the day. So thank you. I hope we get some questions from the audience. I feel like everyone's being a little quiet. We want to hear from you, especially on the issue of mass timber, because there has been a lot of discussion within the fire service on the allowance of mass timber, and that's why we want to hear from you. But I think we have a special guest, Tom Hanover from our building department. Tom, you were intricately involved in the project that came to Cleveland. As a building official, really, what are some of the, and I don't mean it in a negative way, what are some of the pressures that you experience when a project or a proposed project, especially something new that may be considered
How's this gonna work?
So we're very fortunate in Ohio in that the Ohio Board of Building Standards, where the building codes are regulated through, they are our bosses ultimately. They're our regulators, right? So we're the regulatory agency for the city of Cleveland. The Ohio Board of Building Standards is our regulator. Now understand that the Ohio Board of Building Standards, to that point, they're in the Department of Commerce, right? So it's not the Department of Safety, it's not the Department of making sure everybody goes home, it's the Department of Commerce, right? So they're responsible for the movement of money. But the Ohio Board of Building Standards has, in the building code, there's a requirement that as the chief building official, annually, I have to send a request form to the fire service, asking the fire service, do you want to take part in the plan review process? And they get to say yes or no, and then we develop a plan on how they give their opinions on projects. Unfortunately, in the city of Cleveland, we've done that forever. And it's always been part of that. Once upon a time, the building department was in the Department of Public Safety. So our fire service has been our plan reviewers, or at least provided opinions, since, as far as I know, since the first model building code was written in 1889. So we have a great relationship. Lieutenant Alexiak's desk is 26 steps from mine. So I literally walk down the hallway. He and I talk all the time. So that relationship is important because I am never going to fight a fire at any of these buildings. I've fought 2 fires in my life. One, I grabbed my family, we ran out the front door and waited for the big red trucks. And the second one, I was 9 and threw a burning pan of popcorn into the yard so I didn't have to tell my parents. That's it. That's all the firefighting I'm going to do. But we recognize that you're going to be in there. And I do want to take a minute to say, everybody in this room, it's encouraging to see you here for this presentation. And it may be because you need CEUs or because it's a good day to be away from your shop. But this isn't going away, right? There's a huge market, and as soon as before the ink was bought, they're going taller and they're going build bigger. So having this information from your perspective, from the fire service perspective, makes it a lot easier from my perspective as the building official, right? Because I can read all the books and make all the decisions. That those filing cabinets full of AEDs for fire stopping that didn't exist, I reviewed and signed every one of them. And there were many because it was new. And in 2024, with all of our speed of light technology, we're often thinking, well, there's nothing new. It's, we were building like we have for whatever, 6,000 years. But there is no way to fire stop a plastic pipe through or was no way to fire stop a plastic pipe through a cross-laminated timber floor. So we built this building as an alternatively engineered design, taking all of those things into consideration and approving those AEDs. And if it wasn't for the willingness and the participation of the fire service, it would have gotten done. But it would not have, there's a lot of things that would have not been in place at the time for your work, not my work. I get to sign the paper and go home.
Thank you. I appreciate that perspective as well. Young Gun, with the mass timber, we have a number of different species that can be involved in it, number of different adhesives that can be involved in it. And typically, a fire stop system is a defined materials within that system. It's a system. And it's defined material that it's being installed in. Can you talk a little bit about the challenges from a testing company like UL Solutions and the industry? It's expensive to go in and get a listed system. So if we were looking at every type of species, every type of adhesive, needed an individual listing, that would be a cost significant. So from a testing lab, how do you approach this with industry to find a solution for them?
Yep. So as Sean mentioned, so currently, we do not know exactly how each different species will react in fire condition. So that for now at UL, so and yeah, in UL, so you need to specify in the directory. You need to specify each species. For example, the 6 fire stopping materials is listed in UL directory for now, but they are all tested in E1, which is Douglas fir larch. So, but when they tested when if a fire stopping material is specified tested in other CLT, they might have different charting behavior. So that currently we specify that in the UL directory, but as a researcher, as I mentioned in our meeting, in my presentation, so we want to find the most representative CLT species so that can cover all other different species. So that if a new fire stopping materials company develop new kind of fire stopping material, then we want to find we want to test their fire stopping material in the most representative CLT, and if they pass, then we want to cover all other CLT.
Okay.
That's
In addition to species and adhesive types, you also have variation with the number of laminations. You have 3-ply, 5-ply, 7-ply. So there's such a variation. It's almost like as wide as lottery numbers, lotto numbers, because you have 3 different factors all can change in different combinations, and finding the representative sample is the biggest challenge. I had proposed maybe we find the least performing fire CLT, but then how do you go to a manufacturer and go, we're using your product because it's not great.
So I just want to make a point of that. The oldest building material in North America, right, is wood. And it's now the newest building material. And we're doing the fact that we're now categorizing and cataloging based on char ability of wood, which was here long before we got here, right? There was wood on this continent. That just shows the technology and how this, and just an applaud to all of our work, how this industry changes, because we are now doing new tests on wood, which has been around forever, for new reasons.
And can I say that one of the biggest misconceptions about the mass timber buildings is that this was driven by the green building movement. They came to the American Wood Council for technical help at a time when we didn't have a single dues-paying member that even made CLT. That's one misconception. The other misconception Sean touched on is that somehow we're building it, we're pushing it because it's cheaper. It's actually much more expensive, and most of the projects that don't move forward in this country don't move forward because they don't price out. Because if you live in like where Chief Healy lives, where real estate is really expensive, the only way you could add value is to go higher, and you can only go 18 stories according to the code. So if you wanted to build on the New York waterfront or San Francisco or anywhere where real estate is really expensive, these won't price out because they're more expensive. The other thing is that I don't see a ton of these going up because they are limited in size and they don't price out. I see them going on tech campuses, college campuses, places where they care about green building. Now, you might get the occasional show pony like up in Milwaukee. You can't have the tallest building in the world, but you can have the tallest wood building in the world a lot cheaper. So I don't see these, and office space is at an all-time low. So I see these primarily being apartments or condos with maybe retail on the first floor. And I rarely see any of these being built with CLT walls because of the structural qualities of CLT. You just can't go over 6 stories. It's too heavy to put those walls up, and it's really expensive, and people like curtain walls.
Yeah, no, I agree, and I think most of these will be in that 9 to 12 stories range. Chris, you had a question.
Yeah, China Marshall used to describe building a new building as making a 100-year decision, because that's how long you should be expecting a building to last at size. Is there any concern with CLT fatiguing? Because these buildings, they begin to fatigue immediately when the inspection's done and they get occupied. That's the beginning of just the destruction phase of that building. Are you seeing anything with these that you're concerned about as far as how long they'll last?
They have buildings in Europe that have been around for 20 years. Every building material has the same challenge, and that's why they have to be maintained, they have to be inspected, regardless. I mean, you look down at South Beach, Miami, or was the concrete building that collapsed. That happened for a lot of reasons, and it didn't happen because concrete's not a good material. It happened because the building wasn't maintained. They put an aftermarket pool in. They noticed cracks. They didn't put stress gauges on them. There's a lot of reasons why a building can fail. And but if you maintain any building, I mean, the Taj Mahal is built out of wood, and it's been around for 1,000 years or whatever, a couple hundred years, and that's the challenge is maintaining it, and that is one piece of the puzzle the fire service has nothing to do with. It totally rely on responsible building owners.
Well, that's why we put that in there. And that requirement for the annual inspection actually comes from the fire stopping requirements in the code, where we require the owner to inspect the fire stopping annually. It doesn't have to be the fire department, you know, like what we do, you know, you submit your inspection annually. We have another question.
Yeah, just to kind of piggyback off of what Chris said a little bit, I know that moisture control is a major consideration during the construction phase of these heavy timber structures. How much do we know as a fire service about delamination and product dimension changing after long-term water exposure, such as an apartment fire, and long-term impacts on heavy timber products?
Well, I mean, water, it doesn't have a good effect on any building material. So in the case of a fire or in the case of water intrusion, you would have to, just like you would any other wood building, you got to pull the gypboard off, you got to get the fans out, you got to make sure it's dry, you do mold remediation. It's no different than any other wood structure. I mean, I don't have a special answer for you because it would be handled the way it would be in any other wood building. And I don't know of any cases where CLT became delaminated because of water. I mean, it's not a sponge. It does a fair amount of repelling the water.
So what's also a lot of what we considered when we approved intro was one of the benefits of CLT buildings and mass timber buildings is right? So that same amount of water that gets dumped on an apartment fire also infiltrates the concrete into the into the rebar, to the reinforcement. The difference is when wood isn't acting right, when it doesn't look right, when it's not responding right, you're aware of it. Where the failure of, in the city of Cleveland, we just passed ordinances that require mandatory inspections of parking garages, because what we're finding is the 1980s boom of parking garages, that the rebar and the reinforcing steel within the concrete is now failing due to water infiltration and corrosion and oxidation. Well, you can't see it because it's encapsulated in concrete. And then, the concrete also, from the minute it's poured, begins to dry, through hydration. So it's all the same. It's the same with all building materials. The difference is, I think, with mass timber is that it's more prevalent for those maintenance issues.
We have another question.
Actually, I have a two-part question. One would be for UL, if you guys had any plans in the future to do testing with the heavy timber alongside with, like yesterday's presentation with, energy storage banks and stuff like that when they explode, how heavy timber could play a factor when those two are combined. And then my other part was to ask if there was any sort of like mindset or kind of codes or boundaries set for, much like with newer housing development, the wood has gotten cheaper, fails faster. If there's anything for like future, if heavy timber buildings plan to go to that, if there's any kind of parameters to prevent those things from happening.
So when you said energy bank, can you?
Energy store, lithium-ion batteries.
Yes.
Yeah.
Such as, okay. Yeah, at the UL, we have never thought about the energy storage impact on the mass timber. Yeah, but.
So I'll take a crack at that because it's a, maybe it's one of those jokes we have in the fire service. Oh, these mass timber buildings, and now we're going to put EVs in them, and these lithium-ion batteries. But that battery room still has to have the 2-hour fire separation requirements. So you're going to require to be putting gypsum board or another non-combustible material to achieve that. And typically, it'll be 2 layers or 3 layers of Type X gypsum board that'll provide that protection. So the thought process is that gypsum board will protect the wood during the failure of that battery. And then as it relates to the construction of residential and the protection of mass timber, I think I touched on it at the beginning. The dimensional lumber, I think, is of greater concern for me, especially under construction, just because the surface to mass ratio is so much greater than mass timber. It heats up internally quicker, it combusts quicker, it consumes quicker, and it travels. We've had numerous examples of losing whole construction projects on a witnessed ignition. And the fire department, a municipal-based fire department, responded and just couldn't get there in time.
So one of the things, go ahead.
Thanks. I think that was a great question. What's interesting, and for me, your question goes right to where my mindset was at the beginning of this in learning the process with our engineered wood building. I was grateful because prior to this, I'd gone to plans exam courses up at the National Fire Academy. The chief had allowed us to go up there to take our courses up there. And what we have to keep in mind, and this is critical, I believe, for everyone in the fire industry, not just a plans examiner, but chief administration on down. Like, this is the stuff, this is the area where I believe we're falling short. And if I could advocate anything, it would be education in the fire industry at the administration level and up, because there are so many changes that are occurring now within the building. They've been going on. We've all been seeing them, but there's even more that haven't been seen, that are coming across the commissioner's desk, that the gentlemen on this board are seeing, that I'm seeing, that we're getting phone calls on a monthly basis, that the things that are coming, like, how do I put it short and to the point? You haven't seen anything yet.
No,
Okay.
I've seen buildings built out of plastic Lego box, plastic Lego box.
It's coming. And what's going to be critical for the fire industry is we have to get our people educated. I'm saying captains and above, we need to be taking these classes at the National Fire Academy on the building code. A lot of folks, and myself, 17 years on the job before I went into the Fire Prevention Bureau, the fire code's the fire code, that's the red book. Building code's the building code, that's the blue book. That's all I got to know, right? I'm going to be inspecting out of the red book. Wrong. The fire code is already into the building code. That fire code is just maintenance. The building code has the fire code in it already. That building code's saying, hey, not if you get a fire, when you get a fire. When you get a fire, and your building is this type of construction, it's only going to be allowed to have this large of a footprint. It's only going to be allowed to be this tall. The electrical rooms with battery storage, those are going to be 2-hour rated. Your corridors are going to be so wide, those are going to have a 1-hour rating, and it goes on and on and on. That's fire code stuff. That's the stuff that's already in the building code, and that's something that we're weak on. And I was certainly weak on that, and that's why I was so grateful to get in on that track of a plans examiner. It started as an FPI, but that set me on that track for my building code education.
And education's like this as well.
Yeah,
right?
it's huge.
Well, one thing I
Huge.
wanted to say is that about mass timber buildings that I think people get the wrong idea about is when I present, I have a 90-minute class where I present the codes that govern tall mass timber buildings. Well, that's over and above every other code requirement that goes into a tall building. It's not like they're the only requirements. You still have to meet the firefighter communication requirement. You've got to meet every requirement in the code in addition to these extra codes. And the thing about educating higher ups in administration. I gave a talk to, I'm not going to say the state, but it was the, whatever that state X Fire Chiefs Association annual conference. And I gave a talk like this one, similar, but I had code requirements, and it was only about 40 minutes long. And I saw faces glazing over, which isn't unusual, but
I was glazed over while you were talking.
and afterwards, I had a couple of chiefs come up to me and go, "Well, it was too technical. You made it too technical." Well, I don't know how to make the building code not technical. We have a technical job. We're technicians, even at the company officer level, even at the back step level. We're working with technical issues.
So to further answer the question, understand this, and as a carpenter, I've seen virgin wood to quick growth wood, right? Understand that the materials used for this, they're farmed, right? They have farms and that's what makes it such a green industry, is because they plant these trees, they wait 6 years till they get to whatever, whether it be 4 to 18 inches, and then they farm it, and then they just grow around, right? And so because this material is different than the your residential type 5 framing, because those materials are primarily built for housing, and there's very little, because they're so short and they're so small, and because individuals own them, there's far fewer fire requirements or structural requirements, right? They have the stacked construction method, where the materials being used for cross-laminated timber and mass timber are farmed. They're farmed for a specific density and a specific strength, because they have to do more than just structural testing. They have to do fire testing. They also have to do transportation testing, right? Because the entire intro building came through the Port of Cleveland from Austria, right? So the materials themselves, it's inherent that they can't be these, some of the balsa wood type construction that we got. Now, can they never? Never say never, right? But I think that we're not going to be dealing with that problem as we have seen in our lifetime, the change from slow growth old wood to the new mass produced stick frame timbers.
The other thing about the CLT buildings it's not like a pile of 2x4s that you can just frame up and put them anywhere. They're specific to a specific part of that building. They'll be marked 3rd floor, northwest corner. They literally, will be marked. They have to go into a specific location. It's not like one size fits all. And to go into the new growth, I hate to be the one to break it to you. A 2x4 is not 2 inches by 4 inches anymore. There's like 1 inch and 3/4 by 3.5 inches, because they don't have the bigger trees.
Yeah. And that just real quick to that point, it's right. This piece goes here, but it's not just this piece goes here. It goes, this side up, this connection west, this size. It's very specific.
Because the shafts and the utility penetrations are already pre-engineered in it. So that's why they have to go very specific locations.
We got a question from Scott, but you mentioned the quick growth lumber. If you remember, we were successful in getting code language into the residential code to require protection in 1 and 2 family homes based on the research UL did looking at the early collapse of engineered I-joists and that. But when you start to compare the new growth lumber versus the old dimensional lumber, the old growth, it collapses very similar to the engineered I-joists and the metal plate wood connected joists. So it's not your daddy's wood anymore, you're right, it's just farmed.
Can I add one more thing
please.
before? Yeah, so if I add a little bit more about the first question. So as I said, UL Solution does not have that plan, but we are one of the projects that we are doing is measuring the heat release rate of the ESS. So that if we have the heat release rate curve if we understand the ESS heat release rate then using fire modeling, I think we can estimate how long it can sustain. Especially, but the thing is, when we used, let's say, gypsum board, then with the heat release rate, I think we can estimate really, really correctly about how it will sustain. But for CLT, it's the CLT's charging rate is a function of the heat flux. If heat flux is increased, then CLT charging rate is also increased. So so that we, even if we have the key release rate of the ESS, but we need to know one more information, which is, let's say, we have 200 kilowatt per square meters in ESS, then we would need to know the charging rate of that specific species CLT's the charging rate. With that information, I think we can estimate how long it will endure. Yeah, that's as an engineer.
Okay, we have time for one more question. Scott?
You just brought up lightweight truss connector construction. We all know, we're all very familiar with that. We've talked a lot today about the performance of the actual CLT panels. One thing we haven't talked about, what types of connectors are in these buildings and how are those connectors protected?
That's actually what the question I was going to have for Ray, because during our deliberations as a committee, we learned of the failure rates of some of these connections. So Ray, really specifically to you as an industry, you recognize, well, any connection and any type of construction is the weak point, but specific to the mass timber, what is the industry doing to research that, and what is the requirement to protect it?
Well, the problem with connections are, like Sean mentioned, the human imagination. There are so many types of connections out there. There's more types than I could even imagine, and they're proprietary. So it's not like the manufacturers can give us, you know, how they produce them and that kind of thing. There are manufacturer standards, though. So we've advocated for, and it's in the code, that connections have to be protected. To do a concrete comparison, you know, rebar has to have so much cover over it, either inch or 2 inches of cover over the rebar. Well, these connections also need cover, except the cover, instead of being concrete, is wood. So it's all the connections have to be covered. That the covering for the connection has to be the same fire resistance rate as the primary frame. So you have to have, you know, I guess you would call it sacrificial wood over top of it, and it would be behind gypsum. But you're not going to see open connections. But I've seen spline connections. I've seen, you know, metal dowel connections where there's like 30 dowels connecting them. So, so that's, I know, an emotionally unsatisfying answer, but basically it's not the testing of the connections that we can really control. It's the cover and the protection of the connections.
But what's also important is these are not prescriptive connections, right? So with light gauge framing, you have prescriptive. You put this many nails, or you put this kind of a strong tie or this many staples, and it'll make that connection. You know, you don't know who's making the staple. You don't know who's making the nail. This really goes together like structural steel with bolted connections, and then the cover for fire protection. So one of the benefits of this is that they are not prescriptive. They are proprietary. They're specifically engineered to carry a certain weight, to act a certain way in a certain circumstance. They're quality controlled at the manufacturer, and you can't just go to Home Depot and buy 2 shopping carts of CLT connectors, right? They're very specific. So what we did is special inspections, required special inspections on the connectors, the connector installation, the torquing of the bolts, all of those things. We treated it as if it was precast concrete and required all of those inspections, and then required special inspections for the coverage and the connection of the coverage, that, you know, the 4-inch wood that covered it. So the special inspections, going back to the engineering judgments that we required and the alternatively engineered design that I wrote, was with Carl Baldessaro, who was also one of the engineers in the ad hoc committee. All of the special inspections requirements were very detailed as well.
And I just want to say that the majority, if not all, the connections in a CLT building are all direct bearing. So it's not going to be their face connected where if it fails, it collapses. I mean, the CLT direct bears on the glulam beams, which direct bears on the glulam columns. That eventually transfers it down to the foundation.
Yeah, that was a lot of discussion we had in the committee. And, David Barber from Arup shared what he could, but that was the biggest challenge. It was all proprietary. But We know when those connections are exposed, they can't fail early, and that's why the requirement is there. Scott, did you have a question real quick? We have
do.
2 minutes.
Okay. How did the International Code Council allow point access block buildings with single stairwells for multifamily dwellings up to 6 stories?
They haven't.
They haven't yet.
They have not?
We're trying to stop them.
Okay, because
Yeah.
Washington.
Fire Service successfully blocked them at the code hearings last month, but they have an opportunity to come back to the committee. But the challenge is that the proponents are going to the state legislatures and they're trying to bypass the code process. And what we're trying to say is, they're advocating for affordable housing, which, we believe in affordable housing. We believe everyone's entitled to safe housing. But just because of their economic income, they should not have unsafe housing, or they should not sacrifice fire safety for that. And they're trying to flip it, that the fire service is against affordable housing, that we're trying, and that's quite honest, it's bullshit. And, a single stairway in a 6-story building puts that occupant at risk, and it puts the operating firefighters at risk. All of us have seen pictures from the FDNY on 9/11 trying to come up the steps when those stairs the occupants were trying to egress down the same steps.
And they're not even going to states, they're going to cities, big and small.
Yeah.
Baltimore, Denver, Cincinnati, I think, has got something
And
floating
not
around.
just the U.S., also in Canada. And we've been working with Sean McManus up there in
Right.
Canada as well.
So if the state legislator passes it, it doesn't matter, they can't do it? Is that what you're saying?
No, if the state legislature, because remember, the ICC just publishes the code. They have no enforcement authority whatsoever. They're an independent company. Same with NFPA. They publish a code. Then these local states, the individual states, have to go through the legislative process of adopting the code, the specific edition of the code. What are we're 6 years behind?
No, we actually just adopted the 2024, which was based
Really?
off of the 2021.
That's outstanding.
But Ohio has, to that point, there's many Ohioizations in the code where this is the code. For instance, residential fire sprinklers is removed from the state of Ohio residential code. You don't have to put fire sprinklers in 1, 2, and 3 families. Photoluminescent egress markings are not in the. They may have just got in, but they weren't. They were never in the building code. And there's a very specific exception to not sprinkle residential uses if it meets 6 exceptions. That is only an Ohio thing, as well. So that's how that gets done. Is if the state legislature says you have to allow this building, then there's an italicized portion of the building code that's marked as Ohioized, and we have to allow it.
Because the state legislature adopts the code.
Right.
So if they adopt that provision, it's now in the state code.
So one thing, and I know we're out of time, but
That's okay.
I want to make sure that it's important for this group, and I will let the lieutenant speak on it. One of the challenges that we ran into through no real fault of anybody's other than inexperience with the intro project is fire safety during construction. So when you get to, 40 feet for combustible construction, once you get to 40 feet, you have to have a standpipes. There's a specific alarm and guard process that's required out of NFPA. The reality is we don't normally see that, right? Because wood construction is limited to height. So by the time they get to 40 feet in your typical, 4/1, concrete podium with 4 stories of apartments, by the time they get to that 40-foot mark, they're already finished. The fire suppression is in. So it's not common to get to a height where the building is still naked in all wood, and it's combustible, and it doesn't have the standpipe. So if you wanted to, there's a couple minutes you worked through that.
Yeah, no, that was, you hit the nail on the head. Commissioner Vanover is spot on right. We had, before we got into intro, I'd been through, I don't know how many high-rise projects we'd been through from the ground up, from a hole in the ground to steel coming out all the way up, and then all the renovations downtown of the existing high-rises. So it wasn't our first circus, you know, but it really, because it, you know, water supply during construction demolition, you know, I mean, the NFPA has done the statistics on the number of fires that we have. You know, it's over 70% of the fires, I think, they studied occurred during the construction or demolition phases. That's when we're wide open to most susceptible. So we've always been adamant on getting the standpipes up and operating and available and open, you know, or we'll have dry standpipes until they can get the water supply and connected. So that wasn't new to us. But it didn't catch us. Yeah, we weren't ready for, because usually if you're going over 40 feet, we're stealing concrete, you know? And so, and then they're not moving combustibles onto the job site until well after that. So usually there's plenty of time for the pipe fitters and the water department to get their pipe in place, the water connected. We didn't see that.
It was an oh crap moment.
We had
like, oh, wow.
We had the hydrants, and we'd done a great water supply assessment far ahead of the game with the fire protection engineers. But then we had it was like, we got to get pipes in here.
Because that
fitters.
project was really before the ICC published the code with the tall timber building.
Yeah, we were.
So.
Yeah,
Tom was giving direct input on that too,
Yeah.
weren't you?
Yeah, there was 5 stories of buildings sitting at the Port of Cleveland. So that's one of the benefits of, and when you consider cost, you also consider time to market. I mean, the building was stacked. Another thing that goes into that safeguards during construction is they try to bring as much stuff to the site as they can, and promise that there's not going to be a accumulation of combustibles on site. Well, it doesn't take long until they've got panels stacked. But it felt like they dug the hole. Once the concrete platforms for this building were done, they started bringing the concrete cores up. It was, I think, over a weekend, they put 5 stories of timber up. Yeah.
So you had Lieutenant McGowan too. So Lieutenant McGowan is also a plans examiner, and he's an FBI. So Tom was working in the streets. He was the guy on scene, and then I was at building and housing. So the two of us were double teaming this project in terms of addressing the water supply. That was critical. While I was on the horn with the director of public utilities, sorting out the water supply and number of hydrants, Tom was with the people, the fitters, and the water department crews in the field, ensuring that, we had plenty of water flow, because every building has a fire flow, as we all know, whether it's sprinklered or not sprinklered. And then construction sites, we're designing it, before they're, the first truck is moving on site, there's a fire flow assessment. Do they have enough water available right now, for the building they're about to build? Then if we're going to be adding combustibles or storing combustibles, we've got to take those additional hazards into account. So we had plenty of water. We were glad we had done a really good job at that up front. But then as things moved through, because we had done that, once it came to setting up, getting the standpipes going, the pipe fitters, I think it was Communal, was on site, had no issues whatever, getting their pipe and getting things in place.
No, I think we could talk for another hour, but we're past time, so I want to be cognizant and get ready to lunch.
Yeah, you're between me and a buffet.
Yeah, exactly. So, no, thank you, everyone. Really appreciate it. Really appreciate Jim and Tom joining the conversation. I think that was fantastic. Young Gun, thank you. Ray, of course, thank you. They're going to be around for lunch. Again, it's underneath the hot dog downstairs. Let's come back at 1 o'clock. I know we'll fix the time, but 1 o'clock. Thank you.